Today we're working on solving one-step equations with integers, and we're going to move on to the next three examples, which we see subtraction, and the inverse of subtraction is addition, so we're going to use addition to solve. So we see e minus 12 equals negative 4. The inverse of subtracting 12 is adding 12. If I do it to one side, I always have to do it to the other. And negative 12 and positive 12 cancel out, and I'm left with e equals. On this side, I have negative 4 plus 12, and my adding rules say same signs add and keep, different signs, which is what I have here, subtract, keep the sign with the greater absolute value. So in this case, 12 minus 4 is 8, and 12 has a greater absolute value, so e is equal to positive 8. And if I wanted to try and plug that back in, I could to check my answer. I could say 8 minus 12. And does that equal negative 4? So copy, change, different signs subtract. 12 minus 8 is 4. Keep the sign with more, which is negative. So e equals 8 does make sense. It checks and makes sense. On the next one, we kind of have two options. It is a little tricky. We have two options here. We could use copy, change right away on this side of the equation. And make this an adding problem and then subtract. Or we can do the inverse of subtracting negative 3, and we can add negative 3 to both sides. Personally, I think it's easier to copy, change both sides. But if you did it the other way, if you added negative 3 to both sides, you should get the same answer. You would get the same answer. So I'm going to copy x, change subtraction to addition, change negative 3 to positive 3, and x plus 3, the inverse of adding 3 is subtracting 3, and I'm going to do that on both sides. These 3's cancel out, 3 minus 3 is 0, and I get x equals 14 minus 3 is 11. So if I go back to my original equation, it was 11 minus negative 3, and we want to know, does that equal 14? Well, we copy the 11, change subtraction to add, change negative to positive, and 11 plus 3 is 14. So my answer, x equals 11, makes sense and checks. And then at the bottom, we have what looks like a one-step subtraction equation that we're going to solve. But what we're going to find out is that maybe it's not quite as simple as we think. Because the inverse of subtraction is addition. But this is a positive 6, and in order to get positive 6 all by itself, or to cancel out, I have to do 6 minus 6. So that's where we're actually subtracting e, and it gets a little bit confusing, but this is a positive 6. The opposite of a positive 6 is a negative 6. That's the only way, 6 minus 6, that we can get this side to be 0. If we did 6 plus 6, we would get 12 minus e. And we wouldn't be isolating our variable. So that's where things can get just a little bit tricky here. But if you understand that we're keeping things balanced and we're trying to isolate our variable and get it by itself, you understand that we have to do 6 minus 6 to get back to 0. So if I subtract 6 from this side, then I have to subtract 6 from this side. 25 minus 6 is 19. And that's equal to, we can't get rid of that negative sign, that subtraction symbol in front of e. We've got to keep it, and so we've got negative e, or the opposite of e. So the opposite of e is equal to 19. So the other thing that we can do is we can put an invisible 1 in here. Multiplying by 1 doesn't change the value because of the identity property. And so we can say, okay, well, negative 1 times e, the inverse of multiplying, is dividing by negative 1. And 19 divided by negative 1 is negative 19 equals e. And if we were to go back and plug that in, 6 minus negative 19, copy, change, 6 plus 19 does equal 25, which is right here. And so my answer checks and makes sense that e is equal to negative 19. Again, a little bit confusing because on the first example we used inverse operations adding, but on the second example We had a special case where we changed first to make it an adding problem, and then we subtracted on both sides. You can do that again down here, adding the opposite, adding negative e, and then c to subtract. Or you can understand that we're trying to isolate the variable and get it by itself, and in order to do that, we have to do 6 minus 6 to get 0, and that's another special case that we'll do more practice on in class.